Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be understanding a problem on midpoint of a straight line. A straight line is inclined to both the planes, and here the midpoint is the reference point. And with respect to how to draw the projections of the solids, we will be learning this particular problem. Let us see. The midpoint of line AB is 60 mm above HP. So please write down the given data. Here, the given data here, the point is 60 mm above HP and 50 mm in front of VP. So this is the reference point is given, and the line measures 8 mm. So the length of the line is given. Let us consider this is point A and point B, and the length of this line is given. It is 8 mm, and exactly I am locating the midpoint. I am calling it as M, and this midpoint to the end point, this distance is as you know, it is 40 mm. So this particular problem is a midpoint problem. Midpoint is the reference point, right? And now let us look at that. The line measures 8 mm long, and of course it is given that it is inclined at an angle 30 degrees to HP. So theta is 30 degrees. Usually theta is with respect to the horizontal plane, and 45 degrees to VP. So that is angle phi is 45. That is with respect to vertical plane VP. So this is the given data, and you are going to solve this particular problem exactly in 3 steps. So I am just giving these 3 steps. So step number 1, locate the midpoint, that is a reference point. Locate reference point in this particular problem, that is midpoint, reference point, that is M in front view as well as in top view. That is the first step. Second step is draw the true length in front view as well as in top view and get the reduced length. So I am writing it as TL. Locate, draw front view and top view, and subsequently you are going to get the reduced lengths also. This is true length, and you are going to get the draw front view and top view of the line for true length. I am writing it as TL stands for true length. And third step is closing step, that is rotate RL. You have reduced length. When the line is inclined to one plane, you are going to get the reduced length. Rotate reduced length to locus line, locus of B I am calling it as, so that you are going to get the required projections. Let us follow the same steps exactly how to solve this problem. Draw the reference line XY, and the very first step is locate point. Here in this particular problem, midpoint is the reference point, and locate that point, and it is given that it is 60 mm. So here this point is at a distance 60 mm from HP, and 50 mm. I am calling this point as M prime, and in front of it is, this is 50 mm. This is M. So the first step is completed. You have located the reference point, that is midpoint M, in front view as well as in top view. Draw the front view and top view for true length. True length is given, a total length is 80 mm, but as far as our focus is on the second part of the length, that is MB. We are drawing the projections of MB. So let us draw a horizontal line and measure angle 30. This is 30 degrees, and measure 40 mm. This TL, I am calling it as TL here it is 40, true length is 40. So you just draw the projector from this and get the reduced length RL. This is RL, reduced length of TL, and this you call it as it is point B. I am calling it as B1 prime, so that it is B1. So immediately draw the locus of B in front view. Similarly, this angle is 30 degrees as you have erected 30 degrees, and now it is inclined to at an angle 45 degrees to VP. So let us measure with protractor 45 degrees, and this is 45 degrees, and look at the point B. Call this point as B2. This is again TL, true length, and that is 40 mm. Project it up, and so that you are going to get the reducer length. So mark this point. This is B2 prime, B2 prime, and draw the locus line in top view. This is the locus line. This is locus of B in front view. This is the locus of B in top view. Now let us, with the help of compass and this length as radius, that is M prime, B2 prime as radius, draw a circular arc. That is third step. Rotate RL. This is RL. This is TL, and this is RL. Reducer length. So tilt arrowhead I am keeping away. So this is the required point. Call it as B prime, right? And join with M prime with HB pencil. This is the final front view of the above the line. Similarly, M as center, MB1 as radius, draw a circular arc up onto the locus line, and you are going to get this particular point is your B. It is B. Join these two with HB pencil. This is B. So you got the half of the length projections. Now little extension you have to do that in order to draw complete projections. Let us extend the true length line by 40 mm to the other end. Extend it, measure 40 mm. So this you will get B1, it is B1 prime, and this is your A1 prime. This is the locus line. Draw the horizontal line. You have extended this line by, this is 40 mm, right? And extend the final front view up onto this locus line. Final front view. This you call it as A prime. This point is A prime. Similarly, extend the true length line by 40 mm toward the XY reference line. You have extended it. So you got this locus line, draw the horizontal line. This is locus of A, in top view, and this is the locus of A in front view. Now you got it is B2, and this is your A2. This is A2, and extend this final top view upon to this locus line. You are going to get this is B, and the other end is A. This is point A. And if your problem is correct, if you draw a projector passing through A prime, it must pass through A, then only the problem is correct. I hope you understood this problem clearly, midpoint problem. So let us follow these three steps to draw the projections of any line inclined to both the planes, that is HP and VP. Thank you very much for watching this video.